This is our introduction to Redux. Not many of us here, so feel free to stop me anytime, ask a question, ask me to go back. Totally cool. So, first off, let's talk about what is Redux. This is a JavaScript library that's going to help you manage your application state, right? Because today's applications, they manage a ton of state, right? You can be fetching data, you can be caching data, you might have form data that you want to persist for later, right? Session information regarding your user, and all at the same time, you need to keep the user updated on what's happening, right? You know, show a loading spinner, say, sorry, we couldn't fetch your data. Do you want to try again? Or we got your data, whatever it is, right? Our UIs are complex and they move in real time. And so that just makes the state management aspect a lot harder. And as you add more features, your state gets even more difficult to manage. So Redux is going to come in and try to help you manage this stuff a lot better. And state, on its own, this has been, forever, it's inherently complex. If you look at this formula here, you can see that for every, or rather, if you have n states, then the transitions you can have between them is n times n minus 1. So for example, if you have 3 possible states, like you see this picture here, right? You got these buttons. This one can be green, it can be red, or it can be yellow, right? One at a time. If you have 3 states, that means you have 6 possible transitions. So meaning you can go from green to red, that's 1, right? Red to green is 2. Then you can go from, here to here, that's 3, 4, 5, 6. Does that make sense? Yeah. Right? And as you add states, it quickly becomes a lot more complex. So state is complex, and it quickly becomes even more complex. So 3 states means 6 transitions. If you add just 1 more state, you've now doubled the amount of transitions you have to worry about. If you add 2 more, you've almost tripled it. So it grows quickly. Right? So also we have here, this is a state chart that shows like your basic kind of like flow of how you fetch some data. Right? And it's similar to this button example in that you have 3 states, right? The system can be idle, meaning it's not doing anything. It can be fetching, so there's some, a request is gone, we're waiting for it to come back. Or the request came back and it failed, right? The system can be in any one of these 3 states at any given time. And these arrows are the transitions between each state, right? So if you're idle and let's say you click, you say get my data, then now you're in that fetching state. And then if it fails, that failure action moves you from fetching into the error state. Then let's say you can retry and you have success. So this is something to keep in mind for modeling stuff. Also, how many transitions do we say we have here? 6. How many do you see here? Ignore this arrow. How many do you see? 4. How many states do we have here? 3. So according to the formula, we should have 6 transitions, but there's only 4 here. And you want to take a guess. What happened to the other 2? Or maybe why are the other 2 missing? It's not an accident.
They go idle to error directly?
Exactly, and vice versa. So that's 5 and 6 are taken out. See, this is another thing that we have to keep in mind when we're managing state. If you have n states, then that formula tells you how many possible transitions, but that doesn't mean you want every single one of them. Right? So in this case, like Alex said, idle to error doesn't make any sense. Because if the system is just sitting there, it's not doing anything, how can it break? How can something fail? Right? And same thing, if something fails, it can't just magically recover. You have to maybe retry or refresh the page, which is essentially a retry. So state is tough. Right. So Redux is going to help you manage this, as we said. Tried to make the cat jump in at the... Well, I don't think it came out too good. All right. Taken from the first line of the documentation, Redux is a predictable state container. That makes perfect sense to everybody, right? When I first read this, I had no idea what that meant. I was doing Angular back in like 2014. And I was like, oh, cool, predictable state container. All right, whatever that means. But we'll see, hopefully, as we go through the presentation, this actually perfectly encapsulates what Redux is. You understand this, you understand Redux and everything it's about, and the architecture. So we're going to start from the back. What is a state container? State container is, as the name says, it's just a container that holds all of your application state. Right? You can see in this picture here, where SpongeBob is robbing the bank. This bag that he's holding, that is your, you can think of that as your state container, right? It's a bag, it's a box, it's a thing that holds all of your application state, right? And Redux, in its architecture, refers to this state container as the store. Okay, so if you hear the store, you think of this is the state container in Redux. This is where all of my application state is going to go. Questions so far? Redux is not just a state container, it's a predictable state container, which means you can logically follow what's happening or what's going to happen in the store. And the way that is enforced is the Redux architecture. And it has 3 rules. Again, if you understand this, then you understand Redux. First rule of the architecture is you have one store, one single source of truth. Okay? And so Redux, as we'll see in the live coding example, it has this function called create store. Like that, and I think maybe 2 other functions, that's all you're going to use from the Redux API. Redux's API is very, very small. The architecture is the big part. So when you do create store, you get back this store. Okay? And if you do get state, you get the whole application state of that store. So everything that's inside of that state container, right? And anyone tell me, what data structure is this? It's just an object, right? Which is really, really cool. You can actually represent your whole application state as an object. In 99% of applications, this will do the trick. Objects are great. You just need one, and you can put whatever you want inside of it, right? You can put booleans, numbers, you can put other objects, you can put arrays, right? This is an example state of a to-do application. So you can see that the to-dos is an array over here, right? Because we want to have 0 or many. And each one's going to be an object. It has some content. The first to-do says consider using Redux, and a flag that tells you, did I complete this to-do, did I not complete it? Right? You can see it's true for this one, it is false for this one, and we have visibility filter, which you can imagine the UI will read it and says, all right, if the filter is show all, then I'll show all the to-dos. Right? Then maybe you can change to show completed, so show just the completed to-dos. And this is cool, because the UI can just pop into this store, and any value it wants to read, it can just get it from this one place. It's centralized. That is the first thing. Whatever your application needs, right? What's the state? It's going to get it from the store, and the store will respond. That is rule number 1. Rule number 2, your state is read-only. You cannot directly change your state. So like you see here, x equals 3, and then change that later to x equals 2. You cannot do that with your store. That is not allowed according to the architecture, because the equal sign it's not trackable. In this picture, this is an equal sign, by the way. And the store's like, no, stay away, I don't want anything to do with you. And for a really good reason. You get some really cool benefits if you don't allow the equal sign to touch your store. The biggest one is that you can start building a history. Because someone tell me, if you have x equals 3, and then you change it to x equals 2, what happens to that 3?
It's gone.
It's gone. Can you get it back? No. Right? You'd have to log it or write to database. So normally speaking, when you use the equal sign, the previous value is gone. Okay? That's fine for a variable or some calculation you're doing. But for your application state, history can be incredibly useful. And this is what Redux with the architecture can afford you. Let's say, for example, you are a developer working on this big production application. And you get a report from your user that something broke. And then, this is going to cost us millions of dollars. You are the lead developer, you have to fix this. How are you going to go about debugging it? What comes to mind? Console.log? Right? Debugger statements? Alert? History. Okay, normally speaking, are you going to have a perfect history of what happened? Probably not, right? You're probably going to have to maybe get on the phone with somebody or look at a report. Or maybe you'll have screenshots if you're lucky. That says oh, okay, they did this, and that, and this is how the bug happened, right? And you're going to have to step through manually and say, all right, I'm going to do step 1. I'm going to do step 2. And, you know, maybe they remembered correctly. Maybe they, you know, remembered everything they did, and hopefully you can recreate that bug. But there's a lot of guesswork, and it's a manual process. So you may get it, you may not get it. What if, while your user was in their session using the application, you had a history of every single mouse click, every single key press, every single movement they did in the app. And all that information was just sent to a service when the application crashed. And all you do, you get a notification, oh, okay, you know, they had an error. You go down to the server, you get it, and you can just replay the history in the browser. And you can land at the exact same scenario that they had when they encountered that issue. That would transform debugging. And the way that's possible is by getting rid of the equal sign. Okay? So under the hood, the Redux store actually uses the equal sign. It will actually, because you can't change a variable any other way. So the Redux store will use the equal sign to change your state. You are not allowed to use it. The way you change it is by firing actions. So an action is, it has to be an object. Okay? An action is an object in Redux that it must have this type property that tells you what type of action happened. So you can say, like, you know, the type could be clicked enter, right? Submitted form, requested users, okay? Because without a type, you have no idea what happened. And optionally, your action may have a payload. So if you compare these two actions, right? Add to do and get users action. This one is simple. Just, you know, get all of my users. You don't need any additional information. You just know that, okay, I'm probably just going to make a request to this one API and get the JSON back. With this action, though, a payload is necessary. Can someone tell me why? When you're adding a to-do, why would a payload, why would extra information be needed?
Because you just described the to-do itself, and I'm just going to add nothing.
Exactly, right? If I say, hey man, can I add this to the shopping cart? You're like, okay, what do you want to add?
Yeah.
What item do you want to add? So when you want to add a to-do, okay, what to-do do you want to add? All right, you know, we'll call the payload. All right, here it is, buy lettuce. Okay, now it makes sense. I want to add a to-do called buy lettuce. So these are actions in Redux. And so what you do is your user interface is going to be hooked up to Redux. And when you click something or you do whatever, right, you can configure it however you want. Your UI will fire an action that gets sent to the store. The store is going to get that action, and then it's going to create the new states as part of that action. And so this is how you do things, right? You indirectly change state. You don't use the equal sign because you don't have any history. And what's cool about actions is they're objects, right? So you can turn them into JSON. You can turn them into strings. So if every single thing your user does in an application is just an action, then you can store all those actions, turn them into a string, you know, a JSON file, and then you can send them over to a logging service. You can send them to some server, you can put them in local storage, however you want to hold on to them. And then if something ever goes wrong, you can take that file of actions, open up the application in your browser, send every single object through the store, and you'll be at the exact same state that they had on their machine. You don't need a conference call, you don't need to look at some bug report, nothing. All you need to do is replay the actions. And this is really cool. Redux calls this time travel debugging.
This is very similar to what Josh was talking about in his thing last week.
Event sourcing, right?
Event sourcing,
yeah.
right?
There's a lot of overlap with, this is essentially event sourcing, right? Because the UI is your source of these events, and it's firing these actions. And every action, it's something you can track, you can hold on to, right? Since you're not using the equal sign, you're not directly mutating anything, you're indirectly doing it with these actions, so you can hold on to the actions and then use them at any time. That's what's so cool about them. You can, you know, like I said, log them out, store them somewhere. Does that make sense? This is part 2 of the architecture. What was part 1? Somebody remember?
Store system and source of truth.
Well, yes, one store, one single source of truth, right? And then number 2 is you cannot directly access or touch that source of truth. The way you do it is indirectly. Okay. Now, the last rule, it's just as important as the other, of course. So you have the store, your single source of truth. Okay. If your UI needs any state, that's where you go. You're not allowed to directly change that store. You need to do it, you need to intend to change through these actions so that you have that time travel debugging and the history and the benefits and the predictability. But how does the store differentiate between this action and this action? How do you tell the store, when I receive this action, I want to add something to an array state, right? Because if you add a to-do, it's probably going to be a list, right? So you have an array of to-dos, you say add to-do, all right, I want to put something in that array and state. But with this action, I don't want to add to an array, I just want to fetch, probably going to fetch an array from a database or something, right? So how do you tell the store what to do regarding different actions? That is the third piece in the puzzle, that is reducers. And this is probably where people get the most tripped up. So please feel free to ask questions. Conceptually, reducers are simple, but they sound, I don't even know how to phrase it. They seem a lot fancier than they actually are. A reducer is just a function, right? So your store is probably going to be an object. It's probably the easiest way to represent your state. Your actions have to be an object. The reducer is a function. What the reducer does is it takes the previous state and the action that you just fired, and together it decides what's the new state going to be. And it's a pure function, meaning if you give it the same state and the same action, no matter what time of day, no matter how many times you call it, no matter where you call it in your program, you always get back the same result. And this is how time travel debugging is possible. Because if, let's say the user, back to that scenario where they hit the bug in production, let's say they fired 50 actions during that session. You pull those actions from your log and you play them back. Since the reducers interpret those actions, if I fire 50 actions with the same state, and they fire 50 actions and we get different results, the purpose behind time travel debugging is lost, right? So because of that fact, in order for that to work, your reducers have to return the same exact output given the same inputs. Okay? And like I said, they're pure functions, meaning same inputs, same outputs. They can't change their outputs, right? So no equal sign. What else? It can't do any side effects, like behind your back. Like a reducer shouldn't make a fetch call. A reducer should not. It shouldn't even console.log technically, but that's, we can cheat that. So this is your very complicated enterprise-grade user interface. And you have two buttons, right? So this one deposits and this one withdraws $10. So like we said, the user interface is hooked up to Redux, right? You have this dispatcher, okay? And he's responsible for firing actions. So the UI, you click this, you click that, you do whatever. It's going to fire this action that's going to go into the store. And the store doesn't know what to do with it, so it gives it off to the reducers, and they say, okay, if I get a previous state of 0 and an action of add 10, then my new state is 10. So the reducer returns a new state, and that gets sent back to your user interface. This is called the one-way data flow. If anybody's heard that buzzword before, right? One-way data flow, Redux is cool and whatnot, because everything flows one way. Actions to the store, and then the store just comes back after giving it to the producers. Okay? Questions on this? We're going to get to the coding session next. Sounded like you were considering coding?
Like looking. So because two states come out, so it comes out from the reducer, or it just came out? Like first it came out as a state, or did it came out like it came out?
It's really small and hard to see. I wish these letters were bigger. But so this one, right? That's an action, which goes up to the store, and then it gives that action plus the old state to the reducer, and then the reducer returns some new state, which comes back to the UI.
Okay. Yeah.
Because remember at the top of the definition for reducer, it needs the previous state and the action. So it needs two inputs. So that's why it's get the second input from the state object.
Here we go, this animation. All right, so right now it's $0, right? Somebody clicked on, I think, deposit $10. Watch how, you see how it changes to $10? Right? That happened because we're depositing $10, that's the action. Goes to the store. The previous state is 0. The action is give me 10. So the reducer says, all right, I'm going to do 0 plus 10. That's your new state, and that comes back to the UI. Okay, it is time to code.
That was cool.
Okay, so I got two apps side by side. I'll just show you one at a time. There's an update.
That was fast.
Yeah, the beauty of the web. Okay, so here's the first application. This is just a counter, right? So you click this, you go down by one. If you click this, you go up by one. Okay. Here's the code for it. So you can see our actions. Okay, we have the type of increment. We have an action type of decrement, right? So it's just going to be +1, -1. Right? Here's the reducer. Like we said, according to the signature, you take the previous state and you take the action that was just fired. And the reducer, it's usually going to have some kind of conditionals in here. Usually it's a switch case. I just did if statements because there's only two possibilities. But we're going to say if the action that came in, right, because every action is guaranteed to have a type. So if the type is the same as the increment type, which is up here, then we're going to return the previous state +1. Otherwise, we do the previous state -1 if we get the decrement type.
Go back up a little bit.
Sure.
Okay, there we go.
Yeah, I can show you both at the same time.
Okay, I get this.
So do you remember, I think it was slide number 2 or 3, the state charts that I was showing you, right? The button, it can be green or red or yellow, or you can be idle or fetching or error. Remember those arrows that show the transitions? These actions are basically your transitions. These are your arrows. Right? So like your state right now is 0. I have a default parameter here. The state is 0. It's not even an object. It's just 0. And it can only go up and down, because these are the only two actions that I allow in the application. And then here's the reducer that says, all right, if you want to go up, I'll +1. If you want to go down, I will -1. And then you import this from Redux. This will create the store. It's kind of like a factory, I guess. And you give it the reducer. Grab the initial state, and then I just put some HTML here to document it, right? So current state. This is the loop. So I pull in the initial state, which is 0.
So you can code your HTML directly on that.
Yeah. You ever used Code Sandbox before? It's so good for like React, Angular, Vue, regular JavaScript, TypeScript.
You can show it
Pretty much the
like
same thing as CodeCamp.
a portfolio or
Yeah.
something?
Well, Code Sandbox?
Yeah.
Yeah, if you wanted to. Yeah, you can use it for anything. It's perfect for a demo that you just want to get fired up really quickly. And you can, I think you can import from GitHub too, and you can export to GitHub.
Okay, for that, I don't think you can do that on code. So if you want to definitely try it, you should use it.
Yeah.
Hold on, like that.
VS Code also came up with something this morning.
And this thing, dude, this is basically VS Code in the browser.
Oh.
Code Sandbox. Like they copy VS Code as much as possible, so it feels so good.
No, now VS
So
Code.
you like this better than
VS Code shows you all your objects.
I think
on
it's
top.
something CodePen. I don't know.
Yeah.
Well,
I
I
used to think it was.
CodePen is
I've
good for
noticed
like
that lately it
cute
shows
little
you the,
demos,
Oh.
but
the
if
directory
you can make
tab.
like an
Yeah.
entire
Yeah.
application
Yeah.
just
Yeah.
in Code Sandbox.
I saw it this morning. I was like, wow.
Breadcrumbs.
Okay, so remember in this picture, we said that the dispatcher, right, is what fires the actions. So if you look here, I say increment button dot on click is going to be a function that does store.dispatch. That's how you send these messages to the store. The store has a dispatch method that if you put in any object through there, it's going to send it for you. And then same thing with the decrement. So anytime I click on this handler is going to fire. So boom, 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 boom. You can also see the console log.
That is right there in the bottom.
Yeah, and then the stores is an if anybody's heard of observables before, basically you subscribe to the store, and anytime the state changes, it's gonna this function is going to run again. So you can see 11, 12, 13, 14, 15, and whatnot.
Do the one, okay, I never seen subscribe, but do the one that you could bring it back to 0. Can you code it back to 0?
Yeah, sure. Anybody who's not named Premi, because you've been a very good boy this presentation, does anybody want to help me code out a reset button? So I'll make the UI, that's easy, so that does not count as helping me.
In C# or
Reset, okay, ID is going to be reset, and I'm going to query select it here, get element by ID, reset button. Just copy this. Okay, it's going to be stored at dispatch something. So, a good place to start would be the actions.
Yes.
So if we want to reset something, what's a good name for that action?
Of course, reset.
Okay.
Reset with the 2 colons.
Set. Okay. It's going to be an object because every action has to be an object. And we can call the type whatever we want. What type would you call it? Yeah, makes sense.
Why
Yeah.
capital letters? It has to be like that?
Convention.
No, it doesn't have to be like that. Like I can like alt case it like this. You'll see a lot of memes that have this kind of.
I see. I do
this
see.
and it's still going to work just fine. Only because the reducer, when it looks for the types, I'm using this actions constant. So you can call these whatever you want, but I just try to be as explicit as possible. And all of the Redux, well, almost all the Redux stuff I've seen, they make it capital letters. So why not? I'm just kind of following the herd on that one. All right, so we have the reset action. Now, what's the next step?
Let me go to the reducer.
Yeah, the reducer has to look out for it, right? So we can say else if the action type is actions.reset that type, what do we want to return?
State to 0, right?
So state to 0, that sounds like you want to use the equal sign. It's not allowed, remember? So we just return a new value and the store is going to assign it for us. So what do you return if you want to reset?
0.
Yeah, you'd return 0. And if we want to be really cool, we can say const initial state equals 0.
0, okay.
We can set this to initial state, and then we can return initial state. This is a pattern I actually do a lot at work.
This is
A lot of times I'll have something, if you just want to reset all the state in a piece of your app, have a reset action that just returns your initial state. Identify your initial state. We got an error.
35, go down.
You defined it at line 35.
35, 6.
Oh, we didn't finish it.
Oh, this is the app state. Okay, and we'll call it initial app state.
Then you need to change up there. Oh, never mind.
Change that. Okay, cool. So our reducer, and by the way, friend.
Real time, right?
What's up?
Like it's real time, like everything you do.
Yeah. Okay, code sandbox is sick.
Probably a setting that he puts
he
in like
did some
automatically.
configurations behind the back, right? He
Who,
did
me?
some-
Not necessarily. It's not that. Probably not that insane. It's just like you go to that gear thing on the side. It probably just says like update on in real time or something like that.
No, this is a default code sandbox.
Okay.
I've
Is it-
not
you haven't done
changed
anything?
anything, and it comes with prettier, so you don't have to format the code.
Oh. I'm going to uninstall VS Code and use this.
No.
But it doesn't have like the emit completions, does it?
I think it does.
It does.
Maybe, I'm not sure.
What about the JS script?
JSX?
Yeah.
Yeah, of course. It has like React templates for you, which uses create React app, by the way, and you can do unit testing in here too. Right.
then
Also, really cool.
VS Code is good enough.
Since reducers are pure functions, they're so easy to unit test. Just give it state, give it an action, and assert that it gives you the state that you want. So if we wrote a unit test for this, right? Make sure if I give it a reset type, it returns 0. Then I can basically take for granted that this is going to work in the UI.
So quick question.
So
If I have an app, like a web app, okay, and I want to test how many users log into this app, okay, can I integrate the maybe an object in that app and this.
You want to test how many users you have in your application?
Yeah, login, just the login
Like how many people are logging in?
in a day.
Okay, and you want to test for that?
Yeah.
That sounds more like a metric that you would measure.
Yeah.
Like I would expect that to be in like some kind of analytics dashboard or something. You know?
But can't I test that in here?
In code samples?
Maybe having some objects in the app and this like as an object. Putting that
Well, maybe you could like write a functionality that calls analytics thing, and then your test would be, say I have like I make fake 10 people objects are logging in. If under this condition, do I see that in the analytics? Maybe. But I think that would be like outside of one script like this.
Yeah. Other questions?
Go back to your reducer.
What's up?
You go back to your reducer.
Yeah.
At the very bottom, you have a return state at the very end. Is that just like some sort of super weird precaution? Because you only have 3 actions, so it has to be one of those 3, since the user isn't going to directly code a new action or like call a new action that isn't defined. So unless it's like a precaution for later on when you're extending the UI and you haven't yet written new action for it, then you just start going ahead because you forgot it, and then it's like, is that why you have it there?
Yep. What happens is in the application, you do this one more time. Screws. When an action is fired,
Yeah.
and this is not a performance issue in 99% of cases, when an action is fired, every single reducer in the application is notified. This is why actually a lot of times people love Redux for global application state. Because if you have a hierarchy of components, right, it's really easy for a parent and child to talk. But how do 2 components across the tree talk to each other, right? You need to set up all these weird getters and setters and pass props and all this nonsense. So Redux was really good for that. And the way that's done is when an action is fired, every single reducer is notified about it. That's why you always, and see, so let me ask you this now, counter question. If a reducer just returns the state untouched, what does that mean? Because the whole point of the reducer is to take the state and the action and to return some new state. If the reducer just passes through and returns what it got, then what does that mean?
It probably means that the action wasn't possible. You can't have -$10, for example.
It's possible if you code it the wrong way. It is. You're on the right track. You're on the right track. All right, here. Let's ask it a different way. Let's say I have a reducer, because you can have more than one reducer in a Redux application. In fact, you should. If you have multiple concerns, right? Because number 1 in the architecture is you need one store, right? And so that might sound kind of messy later on, right? Because there's just one store and I have 100 pages in my application. That's a big store. So one way to split it up is have multiple reducers that talk to the store.
Do the reducers run one at a time? Or can they like run in parallel all at the same time or something?
That's a good question. I'm not sure.
Because if it runs one at a time, then it makes perfect sense. Because say, in that example that you showed us, that reducer happened to be able to handle all the actions. Or
Yes.
maybe you split it up so that only certain reducers handle certain actions. So then that tree will only check if the action is fired is something that reducer can handle. And if it can't handle it, then yeah, it'll just return the state. Which doesn't mutate the state. So if all reducers run like one at a time, let's say this one over here, I just did 4. Say this one over here does match that action, but all these others don't. This guy checks, can do it, so just return the normal state. Can't do it, return the normal state. Can do it, returns a new state. This guy will also check. He can't do anything, so he just returns the state that was already there, which was the state that was changed by the 3rd action, so that way you still get the new state without other reducers messing it up by like potentially reversing the action. Because like if they were running, say, in parallel, then I think that would make it way more difficult than potentially like erase your state backwards.
Even if they were happening in parallel, if you're just conscious about separating, like if your reducers are truly separated, then they won't step on each other's toes. And that's the whole reason. That's actually another benefit of having pure functions and not using the equal sign. You can parallelize everything and not worry about race conditions. Because even if you run all of them in parallel, they're not changing anything. They're just calculating values. At the very, very end, the store is doing the one mutation, right? Like the mutation is isolated to a single point in your system. So everything outside of that, you can run a billion of them at the same time. Your machine will probably blow up, but that's a different story. It's a different issue. And so for that reason, for parallelization benefits and whatnot. But I'm pretty sure, and we can check in the source code, Redux is like 99 lines long. It's hardly anything. We can actually, right, because the API surface is small. It's the architecture that you're buying into. Most of the code is yours. What was it? I think it just loops through the reducers, and just that final result goes to the store. I think that's how it is, but we can double check later on. Right? So when you fire an action, every reducer in the app is notified about it. And so that's why, like you said, to finish off the question, if I don't care about the action, if it doesn't match any of these, I just return state. Basically, I do nothing. I'm going to assume some other reducer is going to handle it. And if it doesn't, well, no harm done. So, how do we finish this off? We have the reset action. We have the case for reset. We will return the initial state. We have the button. And we have the handler. So, what are we going to dispatch? Actions dot. Yep. And now, I think this will work. Back at 0. Yeah. And see, every time this, you can see it's kind of moving, it's like shaking. I'm just slamming the enter key. Because what I did was, in the subscribe, I put a console log here. Every time something happens, we're notified about it.
Wait, this is like,
Sorry?
where it come from?
Subscribe?
Yeah.
That is a method on the store. So the store has a method called subscribe. You give it a function that anytime you get new state, that function is going to run. So all I do is, okay, let's get the latest state, console log it, and I will update the inner HTML of this guy. Because the first time I render it once with the initial app state. Then, as the state updates, I reset just this. I'm not re-rendering the whole thing every single time. Okay? And so, last questions on this. I'm going to jump to the why. Oh, here we go. I'm going to jump to the to-do list example. It's conceptually similar, but a little bit more complex. Questions on the counter?
So the store only has, or Redux store only has like create store, get store, subscribe, and dispatch as its inbuilt methods, or are there other stuff too?
I don't know if we can step into this. Oh, that's sick. These are TypeScript typings. Create store. Alright, yeah. This is export constants. Let's see how many constants that. Wow.
1.
Yeah, no, but there should be another one. Combine reducers. Yeah. So this is actually how you have more than one reducer in your app. You just give it a hash map of your reducer. So I can call it like, counter will be the count reducer. To do will be the to do reducer. You can have this stuff in a single application. And so, since everybody gets notified of the action, that's why that default state is important.
Okay.
One last refactor before we go to the to-dos. Instead of this, I just want you to get used to this. Usually you'll have, a switch statement, just because it looks a little bit nicer. So, in the case of this type, return state +1. And then, same thing here. Case that, right, return state -1. And then case actions.reset.type return initial state. Now this is obsolete. Oh, also you do need the default case. So default return the state that you received. Okay. And if you look at the application,
Read the break statements.
No breaks.
You don't need breaks?
Nope, if you return, you exit, that's it.
Oh, right.
It's so beautiful.
Yeah.
I don't know switch.
I actually I did not like switch cases until I started using Redux and then Elm. Because Elm, it looks exactly like this. Just not JavaScript. And so this is a lot cleaner if you have a bunch of different types. And that's actually how I did the to-do one. You can see the application still works exactly as we.
Yeah, it's kind of a bit easier to read than a giant if-else tree.
Yeah, it's sweet. You can just go right down.
Yeah.
Okay, here's the to-do example. I'll refresh the browser. Let's move this. Okay, cool. So this is really, really simple as well. Just buy lettuce, buy cheese, groceries.
If there's something like that.
An application like this?
Yeah, and then I print it, and it only print the list. It doesn't print anything around it.
Mm-hmm. Yeah. This is. I didn't do any styles. This is just a shameless markup. So in this case, I have just one action, just keeping it simple. But this time, it's not an object. What is this? It's not an object. Add to do is a
Function.
It's a function, and it returns an object. It returns the action. Anyone want to take a guess? Why did I use a function in this case? Prettier automatically rips these off, but this might help. So when you're adding a to-do, like we said in the presentation, you can't just add a to-do. You have to tell me what name it is, right?
Mm-hmm.
What's it called? What is the application? Right, so how is it going to know?
All right, because the what's it called? The payload is dynamic, depending on what the user put in. So it's not something you could hard code and just return a static object. It has to be something that like would change on the fly.
Mm-hmm.
The easiest way to do that would be a function.
Mm-hmm. Right, the action you generate depends on what they answered. What were you going to say?
I was going to say it has to know what kind of object you're giving it.
Mm-hmm. Exactly.
In this case, you have to tell it you're giving it text.
Yeah, and so, each to-do is going to have its own name. So you need to be aware of that. So this is not an action directly. This is called an action creator. Pretty logical, it creates actions.
Is that the same as an action generating function?
Where'd you get that? Did you get that in Redux?
Yeah, I've heard it in
Then
like
probably,
Redux concepts.
because there's not much else in Redux. So yeah. An action a function that generates actions.
Yeah.
We usually say action creators, but same idea. Right, so the type is static. We know that's going to be add to do. And the payload, that's going to be dynamic depending on what you give it here. So same idea. This time I'm using a switch case. Okay? And again, immutability. I am not using the equal sign. I am not modifying the state. If I did, so state is an array this time. Can anybody tell me why I can't use state.push to add a to do?
Because that modifies it directly.
Because,
No.
yes? Yeah.
No. I don't want to say anything and then.
No, it's fine.
Like this is.
Go ahead.
This is an introduction.
I'm okay.
Alright, so, just like Alex said, if you do push on an array, then you've modified that array, right? You're changing it. And so that breaks the whole idea. Because the whole idea of no equal sign is you can't directly change stuff, right? Let the store do that. So if you use push directly modifies, so that's not allowed. So instead what we do is I create the new to-do, which is going to be this object, right? By default, you did not complete it. And the text is going to be the payload that this action is going to be carrying. And then the new state I create is going to be the old state plus that new to-do, basically concatenating the two. And after that, just return it. And then we have the same kind of code down here. I have the UI, I have an unordered list, and anytime somebody hits the enter key inside of the input, I'm going to dispatch the to-do with the current value that they typed in. And every time we subscribe, I'm going to recreate the list of to-dos. And so you can see here, there's console log on line 56, where I log the latest state. So if I say hello, we get this log. I got this new state. And it's going to be an array of this object. So if I do this now, we get another log. Now we have two objects. So every single time you're creating a new one. Hello, and then log. And every time you do this, here's the latest state, and this is what's getting iterated over and rendered to the browser. And that is my talk.
All right. Thank you.
Thank you.
Did I miss something?
What are you missing in?
Oh, you left.
I had a call.
You just missed all the important parts.
Were you here when I asked why did Yazeed put a default return object in his first reducer example?
Yeah, you were talking about something like that. I remember you said if, let's say, an action is not accepted, another
It could be that a different reducer is handling that action. So just in case that reducer can't do anything with that, it just returns a regular state, pretty much saying, I can't do anything, so I'm just going to leave this alone.
So like, let's say you have two pages in your application, the login page and the dashboard, right? Those are for two different use cases,
Okay.
right? And you have a reducer for each one. If I fire an action on the login page that says sign in, do I want the dashboard to know about that? Not yet, right? So that's why in both cases the reducer is going to say, all right, these 3, 4, 200 actions, I care about these.
Okay.
Anything else, just return the regular state, I don't care about it. Move on. Because when you fire an action, every reducer is notified about it. Right? And just while you were gone, we were stepping through these examples. We finished the reset functionality. Did you see that? Yeah. It was, simple. I moved this to switch cases because this is a lot easier to read than if-else. So if I, receive increment, I'll do this. If I receive decrement, I'll do this. If I receive a reset, I'll do that. Otherwise, I'll just return the state.
Thanks for the presentation.
Yeah, absolutely, man. Thank you for coming.
So, can you walk me through the installation? Is there something like, just like installing packages for like Node or?
Yeah, you did it.
We say what, for Code Sandbox or for Redux?
For Redux.
For Redux? Yeah, just npm install Redux. That's the only one you need.
Okay.
Depending on what you're working with, there could be a more specific version for your library. Like say if you're using React, there is a React Redux, I think.
Yeah, and so
No,
React
you
Redux.
can use the Redux and then you can use with React and then use with other libraries too.
What was it?
So I think you can use with React.
You can use Redux with other things besides React.
Yeah,
So you need
absolutely.
React Redux to make Redux talk to React, right?
Yeah.
So
And I mean, you don't technically need it. So it was a really good exercise for me because I've been using React Redux since I joined my job almost 2 years ago. But it's actually really simple to connect to Redux. When you create the store, just call the subscribe function, and every time you update, change some state, you're going to be notified. That's pretty much what React Redux does under the hood, but it's a bit fancier. It lets you work with components and whatnot, but the source code of it is not anything to be afraid of. Yeah, and so Redux is platform or library agnostic. Like the Angular community, they love Redux because it's an observable, and Angular is all about observables with RxJS and whatnot. React is great. You could probably use it with Vue. I don't know why you would, but yeah. Yeah, and then just the to-do. Instead of an action, I had an action creator. So this is a function that takes the name of your to-do, and it'll generate an action for you. This way I don't have to hard code anything, right? Because every time you add a to-do, it's, you have to tell me what the name is, right?
Oh, okay.
So that's going to generate these action objects, which says, okay, if I receive an add to do action type, I'm going to create a new one, and I'm going to concatenate it to the old state, which is the array of existing to-dos. Return that, and I'm done. And then every time we get some new state, I just take the latest state and just map over them, turning each one into a list item. And so your end result is this.
Okay.
Any questions on that, or?
Oh, okay.
You good? Okay, cool. Yeah, that's all I have.
Thank you. Thank you.